Hey guys, hi and welcome to the video. In this video, we're gonna watch an architecture, basically an episode from AWS. This is my architecture. This would be for 7-Eleven cash-based digital wallet. Without wasting much of time, let's watch the architecture and understand how they have implemented certain things. So let me play that.
Hi, and welcome to This Is My Architecture. I'm Don, and I'm joined by Manish with 7-Eleven.
Hey, Don.
Hi, good day. So tell us a little bit about 7-Eleven.
Yeah, so we are the biggest convenience retailer in the world, and we have been on a digital journey for the last 4 years. Part of the digital journey is 7-Eleven Wallet, and that's what I'm here to talk about today.
Great. So can you talk to us about the architecture that we have on the board here related to the experience with the digital wallet?
Yeah, so our customers interact with digital wallet in two ways. One is at the POS, another is at the mobile device. So let's take an example of a customer walking into the store and trying to enable digital wallet and load $20 on it. So he will go to the cashier. Well, the cashier will cue him to scan the barcode. Now, there is one step needed, which is we want your phone number to be verified if you are using digital wallet for fraud purposes. So you tap on it, you put in your phone number, and your phone number is verified. What we do is the mobile device reaches out to API gateway, which then uses AWS pinpoint to verify that the phone number is a real phone number.
Interesting.
Once that phone number is verified, then he moves on to scanning his barcode at the POS, where the POS then goes to our external ledger, which is being hosted, where the digital wallet details are there, where it says load $20 on that card.
Okay, so I'm assuming since it's external that you're actually leveraging something that's pre-existing?
Yeah, so we had a lot of customers in our existing closed loop gift card system. We didn't want to lose that. Starting from scratch would mean everyone has to transition and time and money. So what we did was we took that and we digitized it by building this, where this stack is what mobile uses primarily, and this direct interaction still stays in.
Okay, so how does that closed loop in the digital ledger, how does that interact with your architecture?
Yeah, so there are two ways it interacts. One, we reaching to the digital ledger from the AWS ecosystem.
Okay.
The other is they coming back. So for the interactions that happen in the POS and go to the ledger, the way we find out about it is there is a message that comes to gateway, and it comes to SQS, and then it's consumed by our Lambdas, and the Lambdas push the data in our database. That way, all changes that happen here, our database stays
They're using a
in sync.
NoSQL.
Now, the interaction which happens reverse, like you ordered something for delivery here, well, the mobile device is going to reach out to API gateway, which again will go to Lambda, and then Lambda would reach out to the digital ledger to update
The ledger
please
to
add,
fetch the data.
and also
Okay.
store it on our database.
Okay, so I assume that this is kind of a near real-time flow from the digital ledger through API gateway, processed by your Lambda functions. So also, I think some key takeaways, the architecture is extensible. You have Lambda functions, you have an SQS message, and then you also have MongoDB, which is going to give you that extensibility from a document store perspective. What is the purpose of EventBridge in this architecture?
Yeah, so we have a stack on the other side of EventBridge that takes care of all customer interactions. So if a customer, we need to update your balance or we need to send out a message to you, all that. So what happens is whenever we need to reach out to the customer, we put a message on EventBridge and it goes out to another ecosystem, which is the loyalty ecosystem. And the loyalty ecosystem will let the customer know your balance is too low, or actually update the balance on the phone or send out marketing messages. That's what sits on the other side.
Okay, so do you work with partners? Is that loyalty system completely homegrown? What's going on over there?
So that stack is our own.
Okay.
Now we do, just like the ledger, we do have an external system there too, which is a loyalty company, external loyalty company. But all interactions directly go from our stack and only use the external loyalty company when there is a loyalty change, like your point balance went up or down, or we award you points for using wallet. Those things go to that loyalty hosting also.
Okay, interesting. So what's next with the overall system?
So the biggest part of this is going to be adoption. Half our customers are cash customers, and we have built this out so that all those cash customers can use our other capabilities like loyalty and delivery and fuel rewards, etc. So the next point would be adoption. We have to get the adoption high where our customers need to trust the ecosystem of and trust us with giving us their dollars, putting it on and using it
That's
for
true.
delivery
Yep.
and other capabilities.
Well, thank you very much for sharing this innovative architecture. This seems like you've taken the same digital experience was for someone who is paying with a credit card. You've brought that to your cash-based customers, and you've allowed them to participate in a rewarding system, a loyalty-based system. Thank you very much for your time today.
Thank you.
And thank you.
It's pretty neat architecture. I liked it. The reason I want to say that is, as you can see, not cluttered with lot many services. The mobile app essentially interacts to the API gateway that can scale on demand. It's essentially none. For the traditional POS system, they have a ledger system, so they can talk to that. For this system, they have basically built up async microservices. So I'm assuming the API gateway puts the message on SQS queue, SQS, then the Lambda polls the queue and processes that. If anything goes wrong, I'm pretty sure, but it's not there, but I'm pretty sure they would be having a DL queue as well, dead letter queue. So if some sort of processing went wrong, that would end up in a dead letter queue. So it's pretty neat and simple architecture. It was really nice watching this. We'll keep watching more and more about This Is My Architecture by AWS. But thank you so much for watching this with me. We'll see you guys in the next videos.